Welcome to the final video for section 5.5, and we are now ready for example number 13. Now, number 13, we are given the concentration in parts per million in a patient's bloodstream X hours after the drug administered is given by the function that's given there. And we need to know how many hours after the drug is administered will it be eliminated from the bloodstream. In other words, where does it come back down to zero? That's when the concentration will be, or that's when the drug will be out of the system. And so the first thing we're going to do is get our big long list of the values that we might try. And this is pretty lengthy because the last value is 108. So that's going to be 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, and potentially 108. In the denominator, luckily, there's only 1. So that means we only have to try 1, 2, 3, 4, 6, 9, 12, any of these up here. Realize we don't even need to try the negative because it's no such thing. We can't go back in time and say, well, 9 hours ago. You know, if we take it now, then you wouldn't have the drug in your system 9 hours ago. So we really only have to worry about the positive also. So let's just say I'm going to try 6 and see if that works. And so I'm going to see, does this give me 0 in the answer? And so let's see what I get. I'm going to use synthetic division, so -1, 15, -66, 108, and I need to put in 0 for the constant because there is no constant there. Okay, now let's try this. -1. Multiply is -6. Add, we get 9. 9 times 6 is 54. Add is -12. -12 times 6 is -72. -72 added here would be, what, 36? 36 times 6 is 216 or something like that. And add, well, okay, we're not going to get to 0. So 6 didn't work. What about 9? -1, 15, -66, 108, and 0. Okay, let's see what we get. -1, -9, 6. 6 times 9 is 54. -12. -12 times 9 is -108. Oh, this is going to be very nice. 0. 0 times 9 is 0. So we end up with 0. So it's all good. So 9 works. So 9 is our answer. 9 is the 0. So what does that mean? That means the answer is 9 hours. Number 14. Number 14 asks us to use the intermediate value theorem to determine whether it has if the function has a 0. Well, the intermediate value theorem says if one end of our range or one end of the interval is positive and the other interval is negative, somewhere in between there has to be a 0. Okay, so all we have to do here is, since we're asking f of x equals -4x to the 4th plus 7x squared plus 4, and it's from -2 to -1. So let's plug in -2. F of -2 is -4 times -2 to the 4th power plus 7 times -2 squared plus 4 equals -4 times 16 plus 7 times 4 plus 4 equals -64 plus 28 plus 4. which is negative. Let's see, negative 32. And then f of negative 1. Negative 4 times negative 1 to the 4th power, plus 7 times negative 1 squared, plus 4. B, negative 4 times 1, plus 7 times 1, plus 4, equals negative 4 plus 7 plus 4, which equals 7. So basically, since one side is negative and the other is positive, there is a 0 between these two. And finally we get number 15, and says the function has a 0 in the given interval, and we need to approximate the solution correct to 2 decimal places. What I'm going to do is I'm just going to simply go to the calculator and see what we get. The calculator, we're going to graph it and we're going to find it that way. That truly is by far the easiest way to go. So I'm going to go to y equals, clear all that out, and I get x to the 4th power minus x to the 3rd power minus 7x squared plus 5x plus 10. And I'm going to graph that. And the thing is, I've got several zeros here. I need to figure out which one am I interested in. Well, I'm told between negative 3 and negative 2. So let's make this go negative 4 and negative 1. And try and regraph it so that we get a little bit more detail here. There's the one I want, right there. That's between negative 3 and negative 2. So I'm going to find that 0, second calculate, find that 0, 2, kind of to the left of it, need to get to the right of it, and then the guess will just fall right there, and I see that it appears to be negative 2.24. So what is the 0? The 0 would be for number 15, negative 2.24.